let's have another discussion, which is our next topic, the correlation and regression. So, another area of inferential statistics involves determining whether a relationship exists between two or more numerical or quantitative variable. For example, educators are interested in determining whether the number of hours a student studies is related to the student's score on a particular exam. Okay, so uh, this is there are many situations in which the relationship exists. Another example, let's have um, medical researchers are interested in a question such as is caffeine related to heart damage, or is there a significant relationship between the person's age and his or her blood pressure? So these are the only few of the many questions that can be answered using the technique of correlation and regression analysis. Now, when we are talking about correlation, it is a statistical method used to determine whether a relationship exists or the relationship between variables exists. And then when we say regression, it is a statistical method used to describe the nature of the relationship between variables, that is positive or negative, or linear or non-linear. Okay, so let's start with, okay, so let's have this question. Are the two or more variables related? Okay, if so, what is the strength of the relationship? Okay, so what type of relationship exists? And what kind of prediction can we make from the relationship? So the purpose of this discussion is to answer these statistical questions. So to answer the first two questions, statisticians use a numerical measure to determine whether two or more variables are related and to determine the strength of the relationship between or among the variables. Okay, so this measure is called correlation coefficient. For example, there are many variables that contribute to the heart disease. Among of them is lack of exercise, um, smoking, hereditary, age, stress, and diet. Of these variables, some are more important than others. Therefore, a physician who wants to help a patient must know which factors are most important. On the third question, you must ascertain what type of relationship exists. There are two types of relationship. We have simple and multiple. In a simple relationship, there are two variables. The independent variable, also known as explanatory variable or predictor variable, using other references. And the other variable is called dependent variable, which is also known as response variable. A simple relationship analysis is called simple regression, and there is one independent variable that is used to predict the dependent variable. For example, um, a manager wished to see whether the number of years salespeople have been working for the company has anything to do with the amount of sales they make. This type of study involves a simple relationship since there are only two variables, the years of experience and the amount of sale. In a multiple relationship, which is also known as multiple regression, two or more independent variables are used to predict one dependent variable. For example, an educator may wish to investigate the relationship between the student's success in college and factors such as number of hours devoted to studying, the student's general average, the student's high school background. This type of study involves several variables. Simple relationship can only be positive or negative. A positive relationship exists when both variables increase or decrease at the same time. For instance, um, a person's height and weight are related. The relationship is positive. Hence, the taller a person is, generally, the more the person weighs. A negative relationship, as one variable increases, the other variable decreases, and vice versa. For example, if you measure the strength of people over 60 years of age, you will find that as age increases, strength generally decreases. The word generally is used here because there are exemptions. Finally, the fourth question asked, what type of prediction can be made? Predictions are made in all areas and daily. Examples include weather forecasting, stock market analysis, sales prediction, crop predictions, gasoline price predictions, and sport predictions. Some predictions are more accurate than others due to the strength of the relationship. That is, the stronger the relationship is between the variable, the more accurate the prediction is. Okay, so this is the uh, correlation. For this discussion, we are only focused to person, product, moment correlation coefficient. Okay, so the correlation coefficient, okay, computed from the sample data measures the strength and direction of a linear relationship between two variables. The symbol for the sample correlation coefficient is small letter r. Okay. The symbol for the population correlation coefficient is this symbol, which is a Greek letter for which is rho. Okay. So the correlation coefficient, okay, as stated, statistician use a measure called the correlation coefficient to determine the strength of the relationship between two variables. Okay, there are several types of correlation coefficients. The one explained in this discussion is called the person product moment correlation coefficient, which is named after the statistician Carl Person, who pioneered the research in this area. So I'll repeat, for this discussion, we only focus to person product moment correlation coefficient. But later on, we are going to encounter some relationship method other than person product moment correlation coefficient. Okay, so let's have this one. Okay, so the range, as you can see here, the range of the correlation coefficient is from 1 to negative 1. Okay, or vice versa, from negative 1 to positive 1. If there is a strong positive linear correlation or a strong positive linear relationship between the variables, the value of R will be close to 1, to positive 1. Okay. If there is a strong negative linear relationship between the variables, the value of R will be close to negative 1. When there is no relationship, okay, or no linear relationship between the variables, or only a weak relationship, the value of r will be close to 0. So that's why in this presentation, so we have here strong negative relationship, then we have no linear relationship, and we also have positive or strong positive linear relationship. Okay, so here in the graphs, okay, as we can see, okay, these show the relationship, the correlation coefficients, and their corresponding scatter plots. Notice as the value of the correlation coefficient increases from 0 to 1, which is the graph A, B, and C, data values become closer and increasingly stronger relationship. As the value of the correlation coefficient decreases from 0 to 1, as we can see in figures or the graph D, E, and F, the data values also become closer to a straight line. Again, this suggests a stronger relationship. Okay. So this would be our interpretation for our R value. So if it is exactly -1, then the interpretation would be perfect linear or perfect negative linear relationship. Then from negative zero point 0.7 to negative 0.99, that means strong negative relationship or strong negative relationship. Negative zero point 0.5 to negative 0.69, that would be moderate linear relationship or moderate negative linear relationship. From negative 0.21 to negative 0.49, that would be weak negative relationship. And from negative 0.01 to negative 0.2, that would be negligible linear relationship. If that would be 0, then there would be no relationship at all. If the R is 0.01 to 0.2, that would be negligible linear relationship. From 0.21 to 0.49, that would be weak positive linear relationship. 0.5 to 0.69, that would be moderate positive relationship. And from 0.7 to 0.099, that would be strong positive linear relationship. And if it is exactly 1, then that would be perfect positive linear relationship. Okay, so let's have an example. So we have here, compute the value of the correlation coefficient for the data obtained in the study of the number of absences and the final grade of the 7 students in the statistics class. So we have here the data. So you have here the students from A to G, and then the number of absences of the students. Okay, so A has 6 absences, student B has 2 absences, C for 15, then D for 9, E for 12, F for 5, and G for 8. And the final grade, okay, of the student in their statistics, for student A, we have 82, student B would be 86, student C is 43, D is 74, E is 58, F is 90, and G for 78. So let's try to compute the R here. The formula for our R would be, we have small letter r, okay, that's equal to, you have n, which is the number of elements, okay, times the summation of x and y, minus, you have the product of the summation of x times the summation of y. Okay. All over, we have the square root of the quantity n times the summation of x squared minus the summation of x quantity squared, okay, times, you have n times the quantity summation of y squared minus the summation of y quantity squared. So this would be our formula. Okay, so let's move to our Excel. Take note that our number of absences would be our x, and and our final grade would be y. Now, uh, in our formula, we have x times y. So first, let's try to get the sum of our number of absences and our final grade. So for that, we are going to have, okay, equal sign, sum, okay, open parentheses, then then highlight those numbers, then close, and then we have that one, and then we have this one, okay, and then let's try to multiply our x and y. To do that, we're going to have equal sign, okay, for the number of absences times the final grade, and equal sign, and then highlight, okay, so that will be our x and y, and then let's add those numbers. And then we also have the square of our x. So our x is number of absences. So this would be our x squared. So what we have is that we are going to multiply this number by itself. Okay, then highlight, and then add those numbers. And then we also have the square of our y. So y squared. Okay. So to do that, let's have equal sign. And then this one multiplied to itself. And then that would be, okay. And then let's get the sum. So the sum is 38,993. Okay, so we already have our sum of x, sum of y, the sum of xy, the sum of x squared, and the sum of y squared. So we can now have the r. Okay, so for our r, okay, okay, so for our r, we have n times x, the sum of x, y. Okay, so our n is 7. There are 7 students. So 1, 2, 3, 4, 5, 6, 7. So there are 7 students. So you have 7. Let's have equal sign. And then let's have 3 open parentheses. We have 7 times the uh, the sum of xy, okay, close, minus you have the product, okay, of the sum of x times the sum of y. So the sum of x, okay, times the sum of y, close. So that is our numerator. Divided by, then our denominator would be, you have open parentheses, okay, and then you have square root, okay, you have the square root of, uh, you have the square root of everything, okay, in the denominator. So let's have uh, another open parentheses, okay, then another open parentheses for n times the squared of x. Okay, so you have the sum of the squared of x. So 7 is our n times the sum of our x squared. Okay, so you have this one. Ouch. Okay, okay. So times, okay, the sum of x squared. Okay, and then you have to close, minus you have the square of our summation of x. So our x is number of absences. Okay, so you have this one multiplied to itself. Close. And then that's another close. Multiply again. Okay. Multiply again to open. You have 7 times our y. Okay. Our y squared. So y squared is this one. Okay. Close. Minus, open parentheses, you have the summation of y quantity squared. So this is our y. Okay, times 2 itself. Close, another close. Okay, the another close is this for 1. And then we have another closed. Oh, that is for the denominator. And then we can get rid of these. Oh, okay. So this must be closed again. This means this is our numerator. So this is included in a single parenthesis. And then the other parenthesis may be disregarded. Okay. Let us check. Okay. So this would be our value of r. You have negative 0.944. Okay. Let's try to substitute these numbers in our presentation. So here, okay, our n, there are 7 students. Okay, 7 students times the summation of x, y is 3,745. Okay, minus the summation of x. For the summation x, we have 57. And the summation of y is 511. All over, you have the square root of, okay, you have n is 7, okay, times the summation of our x squared is 579 minus we have 57, okay, quantity squared, that is for our first, okay, multiplied again by 7 times the summation of y squared, that is 38,000. So we have here our n would be 7, the summation of xy. So our number of elements is 7 times our summation of xy. So that is 3,745 minus, you have the summation of x times summation of y. So that is 57 times 511. All over, you have the square root of, you have the first term, 7 times 579, which is our n, and our summation of x squared respectively, minus our squared quantity of our x, or summation of x, which is 57, times, you have 7 times 38,993 minus the square root of 511. From our computation in our Excel, we come up with the value of r, which is negative 0.944. So this means that there would be a strong negative linear relationship between the number of absences and the final grades of the 7 students in the statistics class. This implies that as the number of absences increases, the final grade of the student decreases. Okay. Likewise, the number of absences decreases, the final grade of the students in the statistics class will increase. So that's the implication of the negative value of R. So as X increase, Y decrease, and vice versa. As X decreases, Y increases. Now let's try to do this one in our Excel, since the computation, the manual computation, is very tedious. So how we are going to do this in our Microsoft Excel through our Megastat. So what you are going to do, remember that this is our X and this is our Y. So our independent variable would be the number of absences, and the final grade would be our dependent variable, since this is affected by the number of absences. So let's go to add-ins, we go to Megastat, then we go to correlation regression, and then we go to correlation matrix. So as you can see in the correlation matrix, this would be the prompt, and then for the input range, we are just going to highlight our number of absences and our final grade. Then click OK. Okay. So this would be our correlation. So here we come up with this one. So as you can see here, you have 0.947 between. Again, take note that this portion would be the sum. Okay. So to make it clear, let's go back. Go add-ins, Megastat, then we go to regression, correlation regression, correlation matrix, and then we are going to highlight only those numbers that is included in our analysis. Okay, and then we go to OK, and this would be our correlation matrix. As we can see here, okay, there would be 4 cells. However, number of absences, by number of absences, that is 1. Of course, we know that that is 1. Okay, now we have final grades and number of absences. As we can see here, we have negative 0.944, which is our value that we obtain in our manual computation. So if in this cell, okay, the color of the font is red, then that means there is negative relationship. But if the color of the font is black, therefore there would be a positive relationship. Now, if the cell, okay, if the cell has the color of this one, it means it is significant at 0.05. Okay, but if the color of the cell is golden yellow, then that means it is significant at 0.01. So this means that if the cell has a shade of yellow, then we are going to reject the null hypothesis. Take note that in our study, in our example, okay, we can actually make the null hypothesis. For the null hypothesis, we could say that there is no significant relationship between the number of absences and the final grade of the 7 students in statistics class. For the alternative hypothesis, we could have there is a relationship between the number of absences and the final grades of the students in the statistics class. So since the cell for the correlation matrix between the final grade and the number of absences has the highlight of yellow, then we are going to reject the null hypothesis. So this means that there is a significant relationship between the final grade and the number of absences of the 7 students in the statistics class. This implies that as the value as the number of absences increases, the final grade of the students will decrease. Or as the number of absences decreases, their grades in statistics will increase. So that's how we are going to interpret the correlation matrix. Okay. So let's proceed to the next, which is the simple linear regression. So this would be the formula for the regression line. Y prime is equal to a plus bx, where a has the formula of the summation of y times the summation of x squared. Okay, minus we have the summation of x times the summation of x, the summation of the product of x and y, all over n times the summation of x squared minus the squared summation of x. For our b, we have n times the summation of x and y, okay, or the summation of the product x and y, minus the summation of x times the summation of y, all over n times you have the summation of x squared minus the squared summation of x, where a is the y-intercept and b is the slope of the line. So in algebra, the equation of the line is usually given as y equals mx plus b, where m is the slope of the line and b is the y-intercept. In statistics, the equation of the regression line is written as y prime equals a plus bx. So in this case, our a is the y prime intercept and the b is the slope of the line. Okay. So let's have this example. So again, with the same data, determine the equation of the simple linear regression line for the data obtained in the study of the number of students or number of absences and the final grade of 7 students in statistics class. Okay, so for this case, take note that we are going to get the summation of y, the summation of x squared, the summation of y, and then the summation of xy, okay, something that. So let's move to our Excel. So take note that our A, okay, for our A, we have the formula, the summation of y times the summation of x squared. So that is equal sign. Then we have this kind, we have 3. Okay, we have 3. Then you have y, the summation of y, the final grade, times, okay, x squared. So this one, close, minus, open, the summation of x, okay, the summation of x, minus, times the summation of xy. So the summation of xy, close, okay, another close, then divided by, we can discard the other. Okay, times, we have 2 open parentheses. The number of elements is 7 times x squared. Our x squared is this one. Okay. Close, minus, you have y quantity, the quantity x squared. Okay, so our x is this one times itself. Okay, close, another close. That means this would be the whole numerator, the whole denominator, and again, this would be the whole numerator. Equal sign. So for our A, we have the value of 102.4925. Or we could round off this one as 102.493. For our B, okay, for our B, we have, okay, 2 parentheses, we have our n, which is 7, okay, times the summation of x squared, xy. So this is our xy. Okay, oops, I forgot to write the equal sign. So times summation of our xy, okay, close, minus you have the, okay, the summation of x, which is the number of absences, times the summation of y, which is the number of final grade, closed. Okay, another close for the numerator. For the denominator, we have two open parentheses again. Then we have 7, okay, times our x squared. For x squared, that is 579, close, minus, open, the summation of, or the squared summation of x. So our x is the number of absences. So this one times 2 itself. Oops. Close and another closed. And then that one. So we have negative 3.6218,905. Round off, we have negative 3.622. So that's how we are going to have our A and B. Let's transfer this one to our PowerPoint presentation. So for our solution, then we have our A. So our A is, you have the summation of y, okay, times you have the summation of x squared, okay, minus you have the summation of x times the summation of xy, all over you have the square root of, you have n times the summation of x squared minus the squared summation of our x. So here, we could have our summation of y is 511, okay, times you have the summation of y squared, x squared rather, is you have, let me check. Oh, that's correct. 579 minus 57 times 3,745 all over. You have the square root of, you have 7 times 579 minus, we have 57 squared. So all in all, that's equal to 102.49. For our y, you have n, not y, that would be our b. So our b, we have our n, okay, times the summation of xy minus you have the summation of x times the summation of y, all over you have, by the way, there must be no square root here. Let me delete. There would be no square root here. There would be no square root here. So here you have n times the summation of x squared minus you have the squared of x. So for our n is 7 times you have xy is 3,745. So 3,745 minus you have 57 times 511 all over you have 7 times 579 minus 57 squared. So that is equal to negative 3.62. So how we are going to do that using Excel, okay, without having a very tedious manual computation. So what we are going to do, we go to add-ins, we go to megastat, then we go to correlation regression, then we go to regression analysis. So for our x would be the number of absences. For our y is our now final grade. Then click OK. Then click OK. So this would be our regression analysis. As we can see here, our R is negative 0.944. Now here we could see here, okay, that our p-value is, okay, in our ANOVA table, the p-value is 0.0014. Therefore, there is a significant relationship between the number of absences and the final grade of 7 students uh, in the statistics class. Now, as we can see here again in our regression output, the intercept is 102.49 round of 3. And then our y-intercept would be negative 3.6219, but round off negative 3.622. Now, the p-value in our number of absences would be 0.014. Therefore, there is a significant negative relationship between the number of absences and the final grade. Okay, so the sign of the correlation coefficient and the sign of the slope of the regression line will always be the same. If they are not the same, then there is something wrong in your solution. Okay. Now, that is if R is positive and B is positive, B will be also be positive. If R is negative, then B would be also negative. The reason is that the numerators of the formulas are the same, and to determine the sign of R and B, and the denominators are always positive. The regression line will always pass through the point whose x coordinate is the mean of the x value, and those y coordinate is the mean of the values of the y, that is x, y. Okay, this means that for our regression line, the equation of our regression line would be you have y that's equal to, so you have, but this is y prime. Okay, y prime is equal to, our a is 102.49 minus bx, 3.62x. If we wish to have this one in the form y equals mx plus b, then you have y prime is equal to negative 3.62x plus 102.49. So our y-intercept would be 102.49, and the slope of the line is negative 3.62. If we wish to see the graph of this one, we go to our Excel. To do that, we go to add-ins, megastat, then we go to correlation regression, then scatter plot. So for our horizontal, which is the y, the final grade, the horizontal would be the number of absences, and our vertical would be the y, which is the final grade. Okay, so we could have this one. Now let's try to see. Okay, so we have this one. So here, our r squared is 0.892. Then the equation of this line, you have negative 3.622x plus 102.493, which is the same of what we had. Now, what is the interpretation of r squared? The interpretation of the r squared is that there is 89.2% of the total variation or the data, okay, is explained by our model. The other 10.8%, okay, is affected by other factors. So I repeat, for us to interpret what is r squared, this would be 89.2% of the total data is explained by our model, meaning it is explained through the relationship of our number of absences. The other 10.8% of the data is affected or is explained by the variables or factors not included in the analysis. So that's how we are going to interpret our r squared. So that's how we are going to have our simple linear regression. Okay, let's have multiple linear regression. So the formula and the calculation of the multiple linear regression is we have yi is equal to you have beta sub 0 plus beta sub 1 xi sub 1 x sub i1 plus you have beta sub 2 times x sub i2 plus so on plus beta sub p x sub ip, okay, plus error. So our y sub I is our dependent variable, x sub I is our explanatory variables or the independent variables. Okay, b sub 0 is our y-intercept or the constant term. Beta sub p is the slope of the coefficients for each explanatory variable or our independent variable. Our E is our model error term. Okay, so the multiple linear regression or the MLR, also known as multiple regression, is a statistical technique that uses several explanatory variables to predict the outcome of a response variable. The goal of the multiple linear regression is to model a linear relationship between the explanatory, which is the independent variables. Okay, take note, variables, that means it's more than two or more rather, and the response variable. In essence, the multiple regression is the extension of the ordinary least square or OLS regression or the simple linear regression because it involves more than one explanatory variable. So the multiple linear regression, okay, which is also known as multiple regression, is a statistical technique that uses several explanatory variables to predict the outcome of the response variable. Okay, this is also the multiple linear regression is used extensively in econometrics and finance inferences. So, what does the multiple linear regression tells us? Simple linear regression is a function that allows an analyst or statistician to make predictions about one variable based on the information that is known about another variable. Linear regression can only be used when one has two continuous variables, an independent variable and the dependent variable. The independent variable is the parameter that is used to calculate the dependent variable or the outcome. A multiple regression model extends to several explanatory variables. The multiple regression model is based on this assumption. So our assumption would be, first, there is a linear relationship between the dependent variables and independent variables. The independent variable are not too highly correlated with each other. Take note, too highly correlated with each other. Okay, the y sub I, okay, observations are selected independently and randomly from the population. The residuals should be normally distributed with the mean of 0 and the variance is and the variance equivalent to our population variance. The coefficient of determination, or the R squared, is a statistical metric that is used to measure how much the variation in outcome can be explained by the variation in the dependent variables. So the R squared always increases as more predictors are added to the multiple linear relationship. Okay. Even though the predictors may not be related to the outcome variable. So we have to take note on that. Okay. So let's have example. Determine the equation of the regression line. Describing the problem-solving ability of the students as affected by the NCAI result or NCAE score and the mathematics grade. So we have this one. Now, the solving of multiple linear regression manually is very tedious because it involves more than one independent variable. So in this case, we are going to use the mega stat. So this would be our mega stat. Okay. Now what we are going to do, take note that our mathematics grade and our NCAE score are our independent variables. And our problem solving is our dependent variable. So what we are going to do, we go to add-ins, megastat, and then we go to correlation, regression, and then regression analysis. So we are going to highlight our independent variables, which is the mathematics grades and the NCAE score. And then for our dependent variable, we go to problem solving. Okay. And then we go to, we click OK. Okay. So this would be our regression analysis. So here, our R squared is 0.346. This means there is 34.6% of the total data is explained by our model. So that's how we are going to interpret this one. 34.6% of the data is being explained by the model. As we can see here, the p-value is 0.0062, which is significant at 0.05. Therefore, there is now a significant relationship between the independent variables and dependent variables. In relation to our null hypothesis, okay, therefore, we have to reject the null hypothesis. So there is significant relationship between the independent and the independent variables and dependent variable. Now, as we can see here, if we go to our regression output, okay, only between the two grades, the two variables rather, the two independent variable, as we can see here, our math grade, okay, has a p-value of 0.77898, which is greater than 0.05. So this means that the mathematics grade is not a good predictor to our problem-solving skills of the students. Okay, NCAI, however, in an NCAI score has a p-value of 0.0084, which is significant, okay, at alpha 0.05. This means the NCAI score is a good predictor to our problem solving skills of the students. Now, if we wish to plot this one in our scatter points or scatter, if we are going to plot this one in our Cartesian plane, okay, we go to our this one megastat and then regression scatter plot, okay, for our clear, okay, for our horizontal, okay, our horizontal axis. In this case, by the way, we could not, before I forgot, uh, we could not have this one. Okay, let's try to see. Okay, as we can see here, we could not plot this one in our Cartesian plane because there are two independent variables. So this is the limitation of the the limitation of the megastat. Now let's go back to our output. Now, by the way, before I forget, okay, we have the equation of our line here would be y. Okay, that would be y prime. Okay, y prime equals, you have our coefficient, our intercept is negative uh, 68.84. Okay, plus you have 0.05 x sub 1, okay, plus 0.956 round off, okay, x sub 2. Let's write this one in our presentation. So we have the regression, the equation of the regression line. So you have y prime is equal to negative 68.84 plus 0.05 x sub 1 plus 0.956 x sub 2. Okay, where our x sub 1 is our mathematics grade, and our x sub 2 is our problem, not problem solving skills. I forgot. This must be NCAI score. So you have NCAI score. Okay, so how we are going to have this one? So this means that our problem solving increased by 1 unit provided that the mathematics grade is increased by 0.05, okay, while the other factors are held constant. Okay, or we could also have this one. The problem solving skills of the student will increase by 1 unit provided that the NCAI score of the student will increase by 0.956 unit provided that all other factors are held constant. Now, because we have this one, we have our our regression line, equation of the regression line, we can predict, okay, the other the problem solving skills. So we could have the values of our x sub 1 and the values of our x sub 2 arbitrarily. Okay. So the result, for example, if the grade of the student is let's say the grade of the student is, uh, let's say 75, and then the NCAI score would be, let's say, 85. So let's say the x sub 1 is 75, and then our x sub 2, the NCAI, let's say 85. So what would be the problem solving score of the student? Then you have, okay, y prime is equal to negative 68.84, okay, plus you have 0 point, oh, this is 0.05, okay, times 75 plus you have 0.956 times 85. So what would be the equation? What would be the problem solving skill of the student with that specific scores? Using the calculator, then the score of the problem solving skill score of the student would be 16.17. Okay, so that's how we are going to interpret the equation of the regression line. If we go back to the simple linear regression, so if we are going to interpret this one, so you have negative, uh, the the grade, the final grade of the student will increase by 1 unit, provided that the number of absences will decrease to roughly four times. Okay, provided that the other factors are held constant. So that's how we are going to interpret. Okay, so that ends our presentation today. Thank you very much.